Welcome to Technically You, where we decode the world of tech one quantum at a time. Today, we're venturing into a realm where science meets science fiction, quantum key distribution, or QKD.
Oh yeah, this isn't your average encryption protocol. This is the next-gen way to lock down your secrets with the power of quantum physics. It sounds futuristic, but it's already happening.
So, grab your digital padlocks and your Schrodinger's cat references because today we're diving deep into what QKD is, how it works, where it's used, and what the future holds.
So what is QKD in plain English? It's a method of generating and distributing encryption keys using quantum mechanics. The magic here is that if anyone tries to eavesdrop, just tries, the communication changes. You'll know.
That's right. QKD doesn't transmit the actual data, just the key that decrypts the data. And it guarantees secure transmission thanks to the rules of quantum physics. So, when was QKD created?
Oh, QKD goes back to 1984. Yep, Orwell would have been proud. Charles Bennett and Gilles Broussard created the BB84 protocol, the first QKD scheme. It was the first practical application of quantum cryptography.
And the idea took off. Since then, scientists have developed a bunch of different protocols and hardware setups, even putting quantum satellites into orbit for secure communication. Now, let's talk about how QKD works.
At its core, QKD relies on qubits, quantum bits, usually photons, sent over a fiber optic cable or even through free space.
Let's say two people, traditionally named Alice and Bob, use these qubits to create a shared secret key. If someone like Eve tries to listen in, the act of observing the qubits messes them up. Quantum mechanics in action.
That's called the observer effect. If the qubits change, Alice and Bob know someone was snooping and can dump the compromised key.
Now, not all QKD is created equal. Let's go through a few common types. BB84 protocol, the OG QKD method using polarized photons. E91 protocol, based on entanglement, meaning the qubits are linked across distance. Measurement device, independent QKD, protects against side-channel attacks, even if the detectors are compromised. And continuous variable QKD, CVQKD, uses standard telecom hardware, making it more scalable.
Each has its own strengths and weaknesses, but the common thread is quantum-level security. So what does QKD protect?
Great question. QKD protects the encryption keys, not the data itself. But without keys, encrypted data is useless. So if you're guarding trade secrets, government data, or financial transactions, QKD adds a quantum armor layer.
And once you have that quantum-generated key, you can use it with traditional encryption methods like AES to protect actual data transmissions. Interesting. So is QKD being used today?
Yes, several countries are investing big in QKD. China, for instance, launched Mischius, a quantum satellite enabling encrypted messages between Beijing and Vienna.
In the EU, the EuroQCI project is working on a continent-wide quantum communication infrastructure. In the US, agencies and private companies are doing pilot tests with quantum-secured networks in cities like New York and Boston.
Our research shows that banks, defense departments, and even telecom providers are exploring QKD for critical infrastructure protection.
Now, let's not sugarcoat it. QKD isn't flawless. It's expensive, hardware-intensive, and currently has a limited range, especially over fiber.
Plus, integrating QKD into our existing internet infrastructure isn't plug and play. But that's where research is heading, making it more scalable, cost-exempt, and distance-tolerant. So what's next?
For starters, quantum internet, yes, that's a thing, and QKD will be its foundation.
Also expect more QKD satellites, longer-range fiber QKD networks, and perhaps, fingers crossed, commercial-grade QKD as part of mainstream internet packages.
As quantum computers become real threats to current encryption, QKD will likely shift from nice to have to must have.
Look, we're heading into an era where hacking tools are evolving faster than firewalls. QKD might be the only true forward-looking defense we have.
It's not science fiction anymore, it's quantum science fact. And it just might save your data from future cyber warfare.
Thanks for listening to Technically You. Like, follow, and hit the bell so you don't miss our next dive into tomorrow's tech. And remember, technically, it's all about you.
So listeners, as always, stay curious.